Okay. Hello everyone, my name is Vlad, I'm a developer at Project Zero. And today I'm here to walk you through an AI agent I built using ElizaOS framework with Project Zero as a data provider for it. Actually, this agent is monitoring Uniswap v2 and Uniswap v3 pairs and pools, track their activities, and update and post updates on Twitter when it detects the high interest pools. So, before we get to the details, let me show that ElizaOS real quick. That is open source project with multiple repositories that provide us actually the framework with packages and tools and utilities to build your AI agent with your own data. You can connect to some clients and have some interactions with your users there. You can describe your character, etc. So I use this framework to build my AI agent. And yeah, just a couple of words to it. Just a really nice project, so I highly recommend you to get in and try something out. So that's it with Eliza. And let's get to some charts. Not charts, it's the diagram. On this diagram, here is a overview of the system. Zero Alpha AI is just a cool name for my AI agent, and what it does is actually getting the data, comes in, do some magics. So actually analyzing the data and decide which pairs are actually has a high interest and post about them on the Twitter. Also, there is a chat UI, the interactive way to interact with the AI agents, ask the questions in the form of the chat, and get some relevant data with the data provided to the agent, and that's it. But when it comes to the data pipeline and how data comes in, especially when we're talking about the blockchain data, it is might be a tricky task. Let's get to the another diagram. Here on the diagram you can see like the so that to make this agent work, we need to accurate and real-time blockchain data. And traditionally, blockchain data is associated through the RPC data providers, which expose an RPC interface for querying blocks, transactions, and smart contracts events. However, tracking this data reliably is complex and multi-steps process that involves like chain organization, data consistency, maintaining scalability, etc. And as you can see here, like it involves multiple steps, like we in the pool querying the data from RPC, or we listen to some WebSocket. There might be some rate limits, it might cost you some money, like we need to handle it, it might fail, so we need to maintain a fault tolerance system. Like we need to check the data consistency occasionally, because some chain rework might happen. It's a common phenomena for all blockchains where several miners competing for blocks to be included into the main chain. So we need to effectively detect forks, detect reworks, and to make the data consistent, so you will get up-to-date and real-time data. Like backfilling data, get the historical data and transfer it to the client as well, and extract some insights and build some knowledge on top of it. And only after that you can feed this data to the AI agent. As you can see, that's really complex multi-steps process that it requires a lot of development effort, a lot of time to be developed, only for that to be data of blockchains to be delivered to your AI agent. So actually, here is the place where Project Zero comes in. This entire pipeline is complex to build from the scratch, but this is exactly where Project Zero comes in. I mean, instead of dealing with RPC limitations, rework handling, and maintaining data pipelines, Project Zero abstracts away these challenges, provides ready-to-use, reliable blockchain data for AI-driven applications. And I'm going to show you in a moment how actually you can use it to build your AI agent. Before we move on to the code itself, I will show you another diagram, like to give you more detailed overview of what has to be done. Here is on the left side, you can see the path 0. This is representation of Project Zero. Instead of all of these data handling, consistency check, chain reorg, etc., we just need our Project Zero stream to be created and deliver data to our webhook handler that is inside of our AI agent. We store this data in our local database, describe a couple of providers, how we can read this data and what we can do with that. Also on top of this providers create some actions that like finds high volume pools, or what is the latest Uniswap v2 pairs, etc. This is actually details of ElizaOS framework and like entities from there. And also there is a like activity monitor, just a while loop that's checking the pools for specific criteria of high volume pairs. And once they met it, we generate some text about it and post it on Twitter. That's nice. And also there is a chat part where you can interact with our agent, just asking like what are the most active pairs in Uniswap v2 on Ethereum blockchain, and it will give you some answers. So let's get to the Project Zero itself. So I think you got the idea, and let me show it to you. Here I have the account on projectzero.io, and let me create our first stream and put some data to our AI agent. So first of all, we have to give it a name, but I'm not so creative and I leave it as it is. So it's each time it generates some random name. It's okay. I like it. Happy Swamp Valley. Nice. Let's stream Ethereum, and also we'll create another stream with Base. So actually my AI agents support both Ethereum and Base. Uniswap v2 events, Uniswap v2 and 3. So let's roll back for 10,000 blocks from real time to get data from latest 24 hours. Let's roughly roll it to 70,000. That's okay. Let's move on. Data type. So actually what I'm interested at is Uniswap logs for tracking pairs and locks, pairs and swaps. Also besides logs, we can transfer the raw block data, block with receipts, block with traces, and receipts, block with traces, receipts and storages, and there are more coming. For now, I just will specifically focus on logs. The batch size, so actually there will be 10 blocks in one batch size, and block function. There is actually cool feature here where we can write some code that will transform the data before it will be delivered to our agent. So actually I don't need all the logs from the blockchain. I just need specifically pairs creation and swaps events from Uniswap. And I prepared some function for it. So let me show it real quick. Here is the function that I'm going to use in the stream. So here you can see the pair created ABI and swap v2 ABI as well for Uniswap v3 pool creations ABI with input out name, event type, and here are the topic hashes. So actually what's that? It's let me find it. Uniswap v2 factory, for example, contract, events, and here you can see events are emitting. For example, pair created, and you can see that the very first topic has the hash, and this hash is immutable. It's always the same for all pair created events. So this hash is actually indicated here. The same I did for pool creations, actually Uniswap v3, for swaps events, for 2 and v3 relatively. And here I am. So actually the final format is here, where we have a block number, block hash, blockchain name, just for my internal case, Uniswap v2, Uniswap v3 with their pair creation. Like, we filter out logs, we just checking is it a pair creation log, we just checking there for topics 0 with the pair created topic. So actually we filter out all the events that are not pair created. Then we decode this data using ABI decoder from Web3 library, JS Web3 library, and then we map it to the format that is we are expecting on our side. It is like pair address, token address, block number, block timestamp, transaction hash. Let's get back to the Project Zero. Oh, let's grab the function itself first. Okay, and put it here. So actually, and let's test it. Here we have some swaps in this block. Okay, there is some data. Okay, nice, seems it works. Let's choose a destination. There are currently 4 destinations supported: webhook, S3, Kafka, and Postgres. For my particular case, I need Web3 because I have a Web3 handler in my AI agent that will like get this data and store it to the database like in the way I want. So actually, so that's what I did. And here you can see the chain organization part. So actually, there is 3 ways of handling chain organizations that we provide. We either don't handle it at all, like if the chain reorg happens and new block is emiss, we do nothing like sending the blocks as they appear on the blockchain. Not recommended at all, but for some needs it might be required. The resend strategy is when we get the new block, I just will resend those blocks that has been reorged just one more time, and the end user is once it gets the blocks that has been already sent before, we just need to rewrite it. That's what actually I did in my agent. Or rollback and response is actually the same as the response, but also first we show the path back to the root of the fork and then send the new blocks forward. I need the resend, I don't need the path back, but for some cases this might be crucial. And let's put the URL to my webhook using some ngrok to forward request to my local instance. And so but first I need to run my agent. pnpm start. Okay, it started. It's starting. Okay, it's listening. Yeah, ready to go. Let's test it. Okay, the session is valid. Okay, I got some event. Okay, perfect. Then let's create it. Okay, it's starting. Like blockchain Ethereum, Sato's running. Okay, it's running, it's already sending some data. It's okay, 70 blocks. 110. Okay, it's pretty fast, already 200. Okay, I can see data is coming. Let me check my database. I have some Uniswap v2 pairs already here. Okay, data is coming. Okay, I can see more and more Uniswap v2 pairs. How about Uniswap v3? There are only 3 pools created so far to Uniswap v3. Okay, Uniswap v2 is still alive. Okay, and swaps events, there are plenty of them. Okay. Okay, let's give it some time to catch up in real time. It's already more than 2000. So as you might remember, there's slightly more than 10,000 blocks to be sent before reaching the real time. But anyway, And also I support the base blockchain. So let's clone the stream. Let's leave the name as it is. I'm not really creative in naming. And choose base. And let's also do the same rollback for 10,000 blocks back. Like roughly 80,000, okay. Continue, select the same logs type. I'll leave the same, and only thing we need to change here is the property blockchain to base. The rest will leave the same because it's actually base is EVM compatible blockchain and it has the same interface as Ethereum. Even the hashes for events are the same, so it's cool for us. Let's continue. The same type webhook, the same resend, and let's test it. Okay, it's valid and create it. And it's starting. Okay. While thinking. Okay, it's already started and yeah, it's gaining traction. Okay, perfect. Let's check on our first stream. It's more than 7,000, it's almost there. But while it's sending streaming data to our AI agent, we already can do something with it. Let me start a client. Our UI chat, where we can interact with our agent. Here we are. So let me ask some questions. What is up? It takes some time. Okay, we got the response. Yeah, so actually the character it's also configurable, but I use Eliza default character. I like it. Like I don't see a reason for me to change it, but I created a really basic AI agent with basic functionality, just here to showcase you how easy it is to build it using our Project Zero. And let me check it again. It's I guess it will be already as real time. It's almost there, I believe. Okay, let me show some question. Ask some question. For example, show me latest Uniswap v2 pairs. Pairs. Sorry for that. Okay. To be honest, the actions are only configured for Ethereum blockchain, so I'm a little bit lazy to support everything. But here we are, we got some information here. So the latest block has been created for 39, like 11 minutes ago. I think we're not as real time. No, I guess we are. So let me check it with the factory. Like some events 10 minutes ago. The address is 1F74. 1F74, okay, and the next one 4DBB. 4DDB, nice. As you can see, we got like up-to-date real data of Uniswap v2 pairs. Maybe there are some Uniswap v3. What about Uniswap v3 latest pools? So actually you can describe some actions in Eliza and describe how to interact with the data from the database and how to represent it, how to work with it. That's what I actually did. I did just pretty basic, like what is the pool, so like what are the most active based on the number of swaps or volume. Here we are. So actually we got the same for Uniswap v3 with the details there, like how, like 7 minutes ago. Nice. So actually here's the real-time data. Let me check our Twitter account if it's posting anything. Yes, here we go. I can see some posts. So actually it's new Uniswap v2 pair gained traction on Ethereum. Nice. And there is a link. I hope it works. Yeah, here we go. Yeah, and here's some newly created pool with many cells and bytes, some volume. Nice, nice. Actually, we got it. Yeah, it's actually the text is AI generated. It just I added some prompts to make it in some kind of style. It includes the link, it indicates the protocol name, the network name, and here we are. So I'm not really expert of creating the Twitter accounts. My previous one was blocked, but anyway, you got the idea of a Project Zero, how easy it is to get the data into any agents that want to work with blockchain data. So I represented to you the block function. I will show it to you again, where you actually can filter out the data before it will get to you agent to get some specific information. In my case, it was Uniswap v2 and Uniswap v3 pair creations, pool creations, and swaps, and that will allow us to have up-to-date real data in the agent. And it was a simple, like, no, all of this data consistency check, RPC polling, chain organization handling. Everything that you need is just a couple of clicks on the platform, and it's sending you data in the matter of seconds once the block appears on the blockchain, and this already will be available at your agent. So I guess that's pretty much it that I wanted to show it to you, and yeah, thank you for your attention. Bye.